them. Second question, quadratic part. Right, so let me just write it down. Oops. You have all these things loose, right? So we're looking at 27 minus 6x minus x squared. Okay? Now, what I'm seeing here is that in the first method that you did, you got x equal to minus 3. And you got x equal to 9. You checked it back to see if it was working out. You checked the answers in the back to see if it was right. Oh no, I didn't. Yeah, I gave you those. All right. So what you could have done is check it to see, if it was working out. But what you want to do is look at the quadratic formula to solve it, right? So when you put this in the way that we know we would like it to be in, it becomes minus x squared minus 6x plus 27. And we're solving it, which means it has to be an equation. This must be equal to 0, equal to 0. Okay, so that's, when it's an equation, when we're solving it, it means that it's in this form. So and so is equal to 0. So if we have to solve this, we first of all have to identify what is A, what is B, what is C, and then we use it in the equation. Now in this one, A is equal to minus 1, B is equal to minus 6, and C is equal to 27. A is minus 1, B is minus 6, C is 27. And the equation that we will use is x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay? So we substitute what we know, minus sign, and in brackets we'll put what b is. B is minus 6. So it becomes very important to put your brackets before you substitute. Plus or minus square root of b squared, which will be minus 6 squared minus 4 multiplied by a multiplied by c. In this case, a is minus 1 and c is 27. So we put minus 1 and 27. So therefore, x will be equal to minus 6 is plus 6. So I'll just write back 6 here. Oh, sorry, all over 2a. So it has to be 2 multiplied by a, which is minus 1. Okay? So let me come down a little lower, right? X equal to 6 plus or minus the square root of minus 6 squared will be 36. Minus 4 by minus 1 is 4, and 4 by 27. 4 sevens are 28, 4 twos are 8, 9, 10. So you get plus 108. Right? Because minus 4 by minus 1 is positive 4. Positive 4 by 27 is positive 108. Then we divide that now by minus 2. This becomes x now is equal to 6 plus or minus the square root of 36 plus 108 is what? 144. All over minus 2. So what happens next? X is equal to 6 plus or minus 12 over minus 2. So what we do then? We come up. See what we have now. Therefore, x will be equal to 6 plus 12 over minus 2, or 6 minus 12 over minus 2. That implies then that x is equal to 6 plus 12 is 18 over minus 2, or 6 minus 12 is minus 6 over minus 2. So we ending up here with x equal to minus 9, or x equal to 3. Okay, so these are the solutions we get in here. So we're not sure if which one is correct. And how you know is you could substitute it in and see. Okay, so let's try and see what would happen. If we were to substitute x equal to 3 in this equation here, let's see what would happen. Okay, bye. Let's see what would happen. If we were to substitute x equal to 3 in this equation, let's see what would happen. After that, we'd say minus 3 squared minus 6 by 3 plus 27. Let's see what happens. Minus 3 squared. So we're going to square the 3. 3 squared is 9. So this becomes minus 9. Minus 6 by 3 is minus 18 plus 27. Minus 9 minus 18 is minus 27 plus 27, which is equal to 0. It means therefore that 3 is in fact a solution. Because if it was not a solution, then we wouldn't get this happening. So it means that you have to check over those two in your method and see where you may have gone wrong with your signs. Okay, you understand? Okay. So that's how we would do that one, and we should, you notice what I asked is if you checked it out to see if it's right or wrong. And that's one secret. You should check it. You're at home, you can check it, see how it's going. Alright? The same question? Third part, yeah. Okay, so what we look at is the third part in the same question next to see if we okay with it. So I'll leave this maybe for 2 minutes so to take down, and then I'll go on to the third part. Okay, so we're looking at this question here, and we want to use the method of completing the square to solve it. Now in the method of completing the square, what we do, we'd have to represent this equation in a particular format. And the particular format is a into x plus h squared plus k is equal to 0. That's the format that we need to get it into. Now we already know what A is. A is minus 1. We need to work out what H is. Now H is equal to B over 2A. That's what H is. And K is equal to 4AC minus B squared all over 4A. K is equal to 4AC minus B squared all over 4A. So this is what we have to commit to our memory, so we'll know it regardless of what happens in the exam. So let us calculate what H would work out to be. H would work out to be B over 2A. B is minus 6, so be minus 6 over 2 multiplied by A. In this case, A is minus 1. B over 2A, which works out to be minus 6 over minus 2, which is equal to 3. So that's what H is. What about K? K is equal to 4 multiplied by A multiplied by C minus B squared all over 4 multiplied by A. So 4A will be 4 by minus 1 by C, which is 27, minus B squared, which will be minus 6 squared all over 4A. A is minus 1. So we just substitute using the brackets. What happens here now? K works out to be equal to 4 by minus 1 is minus 4. Minus 4 by 27 is minus 108. Minus 6 squared is 36, so it will be minus 36. All over 4A, which will be minus 4, because 4 by minus 1 below is minus 4. So this becomes minus 108 minus 36 is minus 144 over minus 4. This works out to be positive because you're dividing signs with the same numbers with the same sign. So that's 4 3s are 12 and 2. 4 into 24 is 6. So therefore K is equal to 6 and H is equal to 3. K is equal to 36, and H is equal to 3. Okay, so we have those two things. Then we'll come here now and start to work out the solution. So let's see how the solution will go. First of all, the required form is that format there. So if we put in now what we know, we could write A, which is minus 1, into x plus h squared. What is h? We know h is 3. Squared plus k. So we're going to put in plus k. Plus k is plus 36. So therefore that's the required format, and we put it equal to 0 now. So that would imply now the minus 1 doesn't have to remain there as minus 1. You could just leave a minus sign. So it could be minus x plus 3 squared plus 36 equal to 0, like this. What's the first step? What we do is remove from this equation the thing that is furthest away from the term in x, and that is the positive 36. How do we remove positive 36? We have to use what is known as the additive inverse, or we do the opposite of adding 36, which is minus 36. So if I minus 36 on the left, I must also do it on the right. The result is we get minus x plus 3 squared equal to minus 36. The next step is, if this is minus x plus 3 squared equal to minus 36, I'm going to divide this side by minus 1 to remove that, and I'm going to divide this side by minus 1 as well. In order to remove this sign, which is minus 1, I'm dividing the left-hand side by minus 1, so it becomes x plus 3 squared. And I'm also going to divide the right-hand side by minus 1, so it becomes 36. Dividing both sides by minus 1. The next thing I'm going to do is to remove the squared sign here. And to remove that, you have to find the square root. Okay. To do that, I have to find the square root. And if I find the square root on the left-hand side, I must also do it on the right-hand side to maintain equality. So I'm going to find the square root on the left-hand side, and I'm going to end up with x plus 3 is equal to the square root of 36 is not only 6, but it's also minus 6. So we must remember to put plus or minus 6 in the solution. What's the next step? X therefore will be equal to, I'm going to remove the plus 3 by doing the opposite of plus 3, which is minus 3. So I'm going to minus 3 on the left side, and therefore I must also minus 3 on the right side. So the right side becomes minus 3 plus or minus 6. This implies that either x is equal to minus 3 plus 6, or the other possibility, x is equal to minus 3 minus 6. In the situation that x is equal to minus 3 plus 6, it means that x will be equal to 3. The other situation is where x is equal to minus 3 minus 6, which says that x is equal to minus 9. And if you realize, this is the same solution we would have gotten when we did the other method. Okay? So have a look at it and see if there's anything you want me to touch base on. If not, you can take it down. Okay, so in this question, we had to solve 6x squared plus 7x minus 24 equal to 0. And we were asked to use the 3 methods to solve it. What we'll do is the method of factors to see what should be the solution in that case. And then we'll be able to take it from that point. Now in this case, A would be 6, B would be 7, and C would be equal to minus 24. So AC will be 6 multiplied by minus 24. And when you multiply 6 by minus 24, what you get? (144) negative. So you get negative 144. Now B is 7. B is equal to 7. So we have to find factors of negative 144 that when sum or added together give us 7. So what we could do, we could write down 6 and 24 here and see what are the factors of 6 and 24. Factors of 6 is 2 by 3. The factors of 24 would be 4 by 6. Good. And we're looking to see what combination we could use to get factors such that when we add them together, we get 7. Okay, so if we use 2 by 4, 8, and 6 by 3, 18, that wouldn't help us. If we use 4 by 3, 12, and 6 by 2, 12, that doesn't help either. So let's see what else, what other combinations we could have. Now this could be broken up into 4 by 6. Sorry, 6 is 3 by 2. Right. So if we look at this combination, 3 by 3, that is 9. And then we look at this combination here, 2 by 4 by 2. So 2 by 4 is 8, 8 by 2 is 16. This combination here would give us 16. And this one here, 3 by 3, would give us 9. Now remember, we're looking for combinations of numbers that when multiplied together will still give us back 144, but we want it negative. And when added together will give us 7. So what I did, I took the 6 by the 24, which was this here, and I started to break it down into factors, like here, and I started to play with the combination of factors and then add them together in my mind to see which one would yield 7, right? So what I came up with by playing around with it is that the 3 by the 3 would give me 9, and the 2 by the 4 by the 2 will give me 16. So now, if you check it out, 9 by 16, if I multiply this, I'll get 144. Check it back, 9 by 16, I'll get 144. And I have to find a combination where I would add 9 and 16 to get 7. Now, we need to get negative 144 because that's what AC was originally. So I'm saying that to get negative 144, I could either have the 9 negative or the 16 negative. But across on this side, I have to choose one of them to be negative such that when I add them together, I get positive 7. In order to do that, it means that the number that has the larger number has to be positive for the answer to end up to be positive. So this will be positive 16 and negative 9. So let's try that. Negative 9 multiplied by 16 will give me negative 144. And negative 9 plus 16 would give me positive 7. So in that way, I would have found the factors of AC, which is minus 144, that when added together, give me the coefficient of x, which in this case is 7, or what we call b. So the required factors are negative 9 and positive 16. Okay, so that's the procedure we went through to get it. It's a little variation of what we did because the numbers were larger than we are accustomed to. So therefore, we could write that this above here, instead of 6x squared plus 7x minus 24 equal to 0, we could write 6x squared. Instead of plus 7x, we'll write minus 9x plus 16x, which we got from our required factors here. We broke it up, and then we have minus 24 equal to 0. So from there now, we're going to factorize this by grouping. And in the first set of terms, first pair of terms, we'll take out the HCF, which will be 3x. So if we take out 3x from there, we'll get 2x. And then if we take it out from here, we'll get minus 3. On this side here, we must also end up with 2x minus 3 in brackets. So we'll place it there, and then we'll take out the appropriate factor. And the appropriate factor in this case will be positive 8. And that was equal to 0. So our next step would be to take out the 2x minus 3 as a common factor from each pair And from the first pair, when we remove it, we'll get 3x. And from the second pair, when we remove it, we'll get positive 8. This is equal to 0. But still, we have some more work to do because we still have to find out what x is. So how do we go about finding out what x is now? We say either the first factor, 2x minus 3 is equal to 0, or the other option is 3x plus 8 equal to 0. That's the other option. So in this first case, if we manipulate this equation, we get 2x is equal to 3 by adding 3 on both sides, or 3x is equal to minus 8. 3x is equal to minus 8 by minusing 8 on both sides of the equation. That would imply now that x is equal to 3 over 2, or x is equal to minus 8 over 3. And if we were to bring it to a mixed number, it would imply that x is equal to 1.5. So if you use fractions, you get 1.5. Or if you use decimals, it would be 1.5. Or x would be equal to negative 3 2s are 6, remainder 2 to make 8. Negative 2 and 2/3. If you wanted to put this in decimals, it would be negative 2.67 corrected 2 decimal places. But you realize that if you use fractions, you have a perfect answer. You have no rounding off to do. Okay? So this would be the solution. Any questions on that? Okay, so the heading is solving simultaneous equations. That's the section we have moved on to now. And below that you write, whenever we have a pair of equations, with a pair of unknowns, whenever we have a pair of equations with a pair of unknowns, then the pair is known as simultaneous equations. Whenever we have a pair of equations with a pair of unknowns, then the pair is known as simultaneous equations. The method of solving a pair of linear simultaneous equations. The method of solving linear simultaneous equations will be shown in the following example. Okay, so the pair of equations that we have are 5x plus 3y equal to 21 and 7y is equal to 20 minus 2x. We have to solve this simultaneous pair. Now, what it means is we have to find the values of x and y that when substituted in both of the equations satisfy them both. Okay? So this is our objective. Now the method that I'm going to show you is a one-off method that you could use to solve any simultaneous equation where both equations are linear, meaning there are no powers and there are no combination of the variables. That's the method we're going to look at right now. Now the first step is to ensure that both equations are in the same form. The form that we will use as standard is this form here, that this equation is in, where you have an x term, then a term in y equal to a number. It doesn't always have to be an x term and a y term. It could be a p term and a q term. For example, this could have been 5p plus 3q equal to 21. All right? It doesn't matter. It just means that the terms are following in that order. If we look at the second equation, we realize that it is not in the same order or arrangement as the one at the top. So what we would do, we would put that equation in that format before we proceed. So this equation here could be expressed, it could be expressed instead of 7y equal to 20 minus 2x, we could express that equation in the same way as the one on the top is represented by adding 2x on both sides of that equation. So if we add 2x on the right hand side, we'll get 20. And if we add 2x on the left hand side, we'll get 2x plus 7y equal to 20, which is in the form of the first equation. So this could be expressed as 2x plus 7y equal to 20. And that is in the same form as the equation at the top, because they both start with a term in x followed by a term in y equal to a number. And that is our objective, to get both equations in the same format. So therefore, I could rewrite my equations like 5x plus 3y equal to 21. And the one below it will be 2x plus 7y equal to 20. Now notice, I didn't start to solve my question in the first part. I didn't go straight into solving it. What I did was bring the two equations that I'm going to work with together, so that I'm not going to have my mind having to drift. I brought them close together, and then I proceed. The next step is to label the equation. So we're going to label the first one, equation 1. And then we're going to label the second one, equation 2. Right? So that's what will be our second step, label equations. The next step, after we label equations, will be to eliminate one of the variables. And the variable that we'll choose to eliminate in this case would be the x variable. And in order to do that, what we will do, we will take equation 1 and multiply it by the coefficient of x in equation 2. The coefficient of x in equation 2 is the number in front of x in equation 2, which is the number 2. So we will multiply equation 1 by the number 2. And after we do that, we'll take the second equation, which is equation 2, and we'll multiply it by the coefficient of x in equation 1, which is 5. Okay, and you'll see what will happen. So let's do the first part that we said, which is this one. Let's take equation 1 and multiply it by 2. So we're going to take this equation and multiply it by 2. So 2 multiplied by 5x is 10x. 2 multiplied by 3y is 6y. 2 multiplied by 21 is 42. So the new equation that we created in this step would be called equation after 2 comes 3. Then we'll take equation 2 and multiply it by 5 as we said. So we're going to take this equation now and multiply it by 5. So 5 multiplied by 2x is 10x. 5 multiplied by 7y is 35y. 5 multiplied by 20 is 100. And we'll call that equation after 3 comes 4. So everything is a very systematic step-by-step process. Then what you'd observe is by following this procedure here, we would have obtained the same coefficient in front of x in our resulting equations 3 and 4. So it means now that we have the ability to remove x from the equations by doing the following. Equation 3 minus equation 4. That's what we'll do next. Equation 3 minus equation 4. So 10x minus 10x is 0x. So I will not write back any x in this position because they subtract one another. 6y minus 35y. That's what we're going to do. 6y minus 35y. What we did before was 10x minus 10x. We got 0x. 6y minus 35y, when you work that out, you're going to get minus 29y. So we'll put that here. Minus 29y. And then we will do 42 minus 100. 42 minus 100 is our next step. And 42 minus 100 will give us minus 58. So right here we will put minus 58. So what we would have found therefore is that y would be equal to minus 58 divided by minus 29. We divided both sides of this equation here by minus 29. And we got what y is. Y works out to be 2. Divided 2, you will get 2. But we have not finished yet because all we have is one solution. We only have the value for y. We have to now find the value of x. So what we will do, we'll go back into any one of these equations, 1 or 2, and substitute for y. Our choice is to substitute in equation 1. So we'll substitute y equal to 2 in equation 1. That's what we'll do. And let's see what happens. If we go in equation 1, which is this here, and we place y equal to 2 inside of there, let's see what we get. We get 5x plus 3 multiplied by y, which is plus 3 multiplied by 2, right, 3y, equal to 21. So it means, therefore, that 5x plus 6 is equal to 21, which means then that 5x is equal to 21 minus 6, which is equal to 15. So therefore, from there, we could find what x is. X will be equal to 15 over 5, which is equal to 3. So now you have solved the simultaneous equation. So you write your answer now. Your answer in a nice format would be x and y. And you're writing what your x value is. Your x value in this case was 3. And your y value in this case was 2. So in that way, you would have solved the simultaneous equations. Okay? Okay, the next area we'll look at is if we have a pair of simultaneous equations where one equation is linear and one is non-linear. One is linear and one is non-linear. What we did previously is when both are linear. In this case, one is linear and the other one is non-linear. The first one, x minus y equal to 3, that is the linear equation. And the second one, xy equal to 28, that is the non-linear equation. So that one is non-linear, that is the xy equal to 28 is non-linear because there's a combination of variables. It would also be non-linear if there's an x squared term or a y squared term present. Okay? Now, in this case, what we do is we express x in terms of y in one of the equations or from one of the equations. So we will take equation 1 and express x in terms of y. Okay, so let's label it up first. So we'll call this one equation 1 and we call this one equation 2. Now, what we could say is from equation 1, we could say that x will be equal to 3 plus y. How did we get that? We add y on the left hand side and we add y on the right hand side. So what happens is you get x only on the left hand side and you get x equal to 3 plus y. And we'll call that one equation 3. 1, 2, 3. The third equation is equation 3. Okay? Having done that, we'll make a substitution. We will substitute x equal to 3 plus y in equation 2. And the reason is that we'll then have an equation with only one variable in it, and that variable will be y. So what we'll do, we'll substitute x equal to 3 plus y into equation 2. So let's see what will happen when we substitute x equal to 3 plus y into equation 2. What it means is that instead of x, I'm now going to write 3 plus y because x is 3 plus y. So I'm going to put it there, and I'm going to put it using my brackets because remember when we substitute, the brackets around what you're going to substitute helps you not to make errors. Very important. So instead of x, I'm going to write 3 plus y right here for x. That means x by y, so I'll have to put y here because x is now 3 plus y from below, and I'm going to multiply that now by y, which is why I have this here. And that would be equal to 28. 28, like this. So 3 plus y multiplied by y is equal to 28. So now, what I'll do is expand that relationship. So I'll say y by 3 is 3y. That's this. And then y by y is y squared. Would be equal to 28. So 3y plus y squared equal to 28. And this is starting to resemble a quadratic because you observe that there's a term in y squared, there's a term in y, and then there's a constant. And we know how to solve quadratic equations. We know 3 ways to solve them. So let us put it in the form that we are comfortable in solving. That's why we learned, one of the reasons why we learn how to solve them. So I'm going to put this in a format that we know by removing 28 from the right hand side. How do I do that? I minus 28 on the right hand side. So minusing 28 on the right hand side and rearranging the left hand side to what we are accustomed to, we'll end up with y squared plus 3y minus 28 is equal to 0. Because I minus 28 here on the right, I minus 28 on the left, and I rearrange the remainder into a format that I'm comfortable with. This is a format that we're familiar with. Something squared, something with a number in front of it, and then a constant term. This is a quadratic that we have formed here. This is a quadratic equation. In this quadratic equation, A will be equal to 1, B will be equal to 3, and C is equal to minus 28. So I'm going to find AC, and I'm going to find B. AC in this case would be 1 in front of the y squared by minus 28. 1 by minus 28 is minus 28. And B in this case is the number in front of y here, which is 3. So I have to find the factors of minus 28 that when added together give me 3. And those numbers you would probably see very quickly would be the numbers minus 4 and 7. Because minus 4 by 7 will give me minus 28. And minus 4 plus 7 will give me 3. So therefore, I would have found the required factors. Therefore, the required factors are minus 4 and 7. So based on that, I could come back up here now and make that substitution. How will I do it? Y squared plus 3y will be replaced by these two here. So I'll replace the plus 3y by minus 4y plus 7y minus 28 equal to 0. Then I'll factorize by grouping. So I'll take out y from the first pair and I'll get y minus 4. And I'll take out from the second pair in order to get y minus 4. What I'll take out is plus 7. And that will be equal to 0. So what happens then is that I get y minus 4, y plus 7 equal to 0. And we know how to solve this. That means either y is equal to 4 or y is equal to minus 7. How did I do that? Either y minus 4 is 0 or y plus 7 is 0. And if y plus 4 is 0, then y is equal to 4. And if y plus 7 is equal, then y is equal to minus 7. Okay, so this is the procedure we had learned to solve when we were doing the previous exercise. How is this going to help us now? Well, remember, we still have to find x. Because in a simultaneous equation, we have to find the values of x and the values of y. But by now, what you're recognizing is that because one of the equations are nonlinear, that is equation 2, you have two solutions for y, and therefore two corresponding solutions for x. So we'll find the corresponding solutions for x now by simply going to an equation that will make it easy for us to find it. An equation that I'm going to use, I'm going to select is equation 3. Because in equation 3, what happens? I have x equal to 3 plus y. Very easy for me to find x. So I'm going to substitute y equal to 4 in equation 3. And what am I going to get? I'm going to get x is equal to 3 plus 4, which is equal to 7. And I'm also going to substitute now the other value for y. The other value for y was y equal to minus 7. So I'm going to substitute that now. Substitute y equal to minus 7 in equation 3. I'm going to do that now. What does that mean? It means that x is equal to 3 plus y, which is 3 plus minus 7, which is the same thing as 3 minus 7, which is equal to minus 4. So now, in a nice, comfortable way, you could write your answer. And how is that? Let's write the answer down. The answer will be given in this manner. You write down what x is and what y is. And in this case, you put 2 blocks. Because now, you have 2 values for x and 2 values for y. Not so? So let's see what we have. X is equal to 7 when y is equal to 4. So I'll write it. X equal to 7, y equal to 4. And then the other one we got was x equal to minus 4 when y was equal to minus 7. So x equal to minus 4 when y is equal to minus 7. Okay? So that would be the entire solution for a question of that type. Okay, so the next thing we go on to is inequations. And write the following. A linear inequation with one unknown, is an inequation which can be written in the form ax plus b is less than 0, or ax plus b is less than or equal to 0, or ax plus b is greater than 0, or ax plus b is greater than or equal to 0. Where a and b are real numbers and x is the unknown value. Okay? So that's what a linear inequation would look like. Of course, this sign here we said means less than. That sign means less than. This one means less than or equal to. This one means greater than. And this one means greater than or equal to. greater than or equal to. And two examples of what an inequation could be like might be 2x plus 5 is less than 0 as one example. In this case, a would be 2 and b would be 5 in that particular case. Another example that we could look at might be 3x plus 2 is greater than or equal to 0. In this case, a would be 3 and b would be 2. Okay, so those are some examples there. Okay, so underneath our heading, which is solution of linear equations with one unknown, there's a strategy that I will call out for you and you just take it out. You write in these inequations, we follow the same procedure as that for equations. We follow the same procedure as that for equations with one unknown. Except for the situation where we must multiply or divide throughout by a negative number. Except in a situation where we must multiply or divide throughout by a negative number. Full stop. When this occurs, we must simultaneously reverse or switch around the inequality sign. Full stop. In all cases, the solution is not a single number. In all cases, the solution is not a single number. But instead, but instead a solution set. But instead a solution set which can take a range of values, which can take a range of values which can take a range of values and be shown on a number line. And be shown on a number line. So if we had these examples where we had to solve the following, and show the solution set on a number line. Right? That's what we had to do. Solve the following and show the solution set on a number line. And the first one was we had to solve x plus 2 is greater than or equal to 7. X plus 2 is greater than or equal to 7. The method is exactly like what we would have done for equations. So as an example, what we would do here, we would minus 2 on both sides. So we would end up with x is equal to, if we're showing it step by step, plus 2 minus 2 is greater than or equal to 7 minus 2. What we did was we minus 2 on both sides, and that would imply that x is greater than or equal to 5. X is greater than or equal to 5. Now that is a solution set because x could be any value that is greater than or equal to 5, which means x could be 5, 6, 7, 8, 9, 10 to infinity. It's an infinite set of solutions. That's why we call it a solution set. As a matter of fact, x could be anywhere that is greater than or equal to 5. It could be 5, 5.5, 5.6, all the way up uncountable, right? And if we had to show this on a number line, right? A number line could be used to show this solution set. What we would do, we would come up with our number line, first of all, and 5 being a critical point. So we'd have 5 here, 4, 3, 2, 1, 0. Right, that's our number line there. And if we had to represent, let's say this is 6 going on. If we had to represent this situation where x is greater than or equal to 5, we would circle the 5, like what we did here. Circle it. And because there's an equal to sign, we would have to shade it in. Like that. Because this equal to part on it. Shade it in well. And then we would have to go to the right because x is greater than 5, which means that you have to go in this direction. Because on a number line, when you go to the right, the numbers get larger. So this is how you represent the solution set on a number line, and this represents a solution set. Okay, so take that. Okay, another example is if we had to solve x minus 3 is greater than 4, as in number 2, and show the solution on a number line. Here we would say x minus 3 plus 3 So we get x by itself on the left hand side is greater than or equal, is greater than, 4 plus 3. So we add 3 on both sides, and what we end up with is that x is greater than 7. X is greater than 7. How do we show that on a number line? Well, what we do is we come up first of all with where 7 would be. So you could go all the way as 1, 2, 3, 4, 5, 6, 7, and maybe one more, 8. And we know x is greater than 7. So we're going to start at 7 with our circle. But in this case, we are not going to shade it in because you observe that unlike the first example where we had the equality sign, in this case, there's no equality sign here. So it means that we do not have to shade the circle. All we have to do is identify if it's going to the right or to the left. In this case, it's going to the right because x is greater than 7. And we know as we go to the right on the number line, we get greater than. So you go to the right, shade it in like this, and then you put your arrow pointing to the right. So that would be the number line that points out the solution set for number 2. So draw that up. Okay, our third example. Let's change it from the greater than side to the less than side. So let's change that out. So we'll see an example of less than instead of greater than. Let's remove this. And put in the less than sign now. Okay, so in this case, how would we solve it? Well, we multiply throughout by the 3. So we get 3 by 2x is 6x. 3 by minus 1 is minus 3 is less than 6. Then what we would do is we would add 3 on both sides. So we'd end up with 6x is less than, and if we add 3 on the left hand side, it cancels out the minus 3. If we add 3 on the right hand side, we get 6 plus 3, 9. Then what we'll do next is we'll divide both sides by 6. So we'll get 6x divided by 6 will give me x. And if I divide 9 by 6, I'll get 9 over 6. So then this could also be written as x is less than 9 over 6 is the same thing as 3 over 2 if we divide top and bottom by 3. So we get x is less than 3 over 2, or we could say that x is less than 1.5. So if we had to represent that on a number line, what we would do is we'd get our 0 position, our 1 position, our 2 position. And if we have to get 1.5, it'll be halfway between the two of them. So let's say 1.5 is about here. That's 1.5. And then it's less than 1.5. So we would circle the 1.5. We would not shade it in because there's no equal part here. It's just less than. And to get less than, we have to go now to the left. So this has to be shaded in with the arrow in bold like this. And that would represent x is less than 1.5. So to write it in, this will be x is less than 1.5. The one before, which is number 2, is x is greater than 7, which is this one. And the one before that was x is greater than or equal to 5. Okay, so each of those number lines would represent your the various solution sets. Okay, so what we look at now are two important examples because they illustrate here the difference between when we solve linear inequations and when we solve linear equations, right? In this example, let us go through and see what the difference is here. Now, the first thing we'll do is get rid of the minus 2 on the left-hand side by adding 2 on both sides. So we end up with minus 10x minus 2 plus 2 is greater than 3x minus 15 plus 2. What we did, we add 2 on both sides. So what happens then is we get minus 10x is greater than 3x minus 13. Okay? The next thing we'll do is we will remove the 3x from the right-hand side. You could have chosen to remove the minus 10x from the left-hand side, but for this particular example, we will be removing the 3x from the right-hand side. And in order to do that, we have to minus 3x on the right-hand side, like this. Remember, the minus 13 was still there. We didn't interfere with that. If we minus it on the right-hand side, we also have to do the same thing on the left-hand side. So we'll do that now. Minus 10x, and we'll minus the 3x on the left-hand side as well. So what we did was minus 3x here and minus 3x here. The result is that you'll end up with minus 13x is greater than minus 13. And it's at this point here, the next step is where we have the difference coming in here and what makes it important. Because in order to solve for x, what we will do is we will divide the left-hand side by minus 13 so that we'll get x on this side, the left-hand side. And we would be tempted to put the greater than or equal to sign like this and have minus 13 over minus 13 because we were dividing on both sides by minus 13 if we were following the same rules as equations. But we do not do that. What we do instead of having the greater than sign, we have to switch the sign at this point, so it now becomes a less than sign. That's what makes this an important example. Because whenever we have to multiply or divide on both sides, as in this case of the equation, or the inequation, sorry, then we have to switch the sign. So here we switch the sign from from greater than to less than. And that's what makes it different. So the answer here comes down to be x is less than 1. X is less than 1. The answer comes x is less than x is less than 1. Okay, so we'll do one more example and then we close off of this situation. Okay, so another example of a situation where we would have to reverse the brackets, reverse the sign, is in this case here, where we observe that x is being divided by minus 2. So in order to solve for x, we'd have to multiply both sides by minus 2. And the rule says that whenever we have to multiply or divide both sides of the inequation by a negative number, we have to switch the sign. So in this case, because we have to multiply both sides by minus 2, we'd have to switch the sign. So it becomes, instead of less than or equal to 1, it becomes greater than or equal to 1 by minus 2. So what in effect happens is that you get x is greater than or equal to minus 2. And if we had, in this case, to represent that on a number line, what we would do is pick up the 0 position, minus 1, minus 2, minus 3, and so on. If we have to go x is greater than or equal to minus 2, we'd find where the minus 2 is. Because it's greater than or equal to, we'd shade it in. And then, if it's greater than, we'd have to go to the right. So that would be the number line for that particular solution. It was an interesting one, different from the others. That's why I did the number line for this situation here. Okay? So with that, we'll close off this session. Okay, so we're going to look at solving 27 minus 6x minus x squared equal to 0. All right, and we look at each of the three methods and see how to get this done. The first method we'll be using is the method of factors. And before we embark on any one of the three methods, we must first ensure that we have the question in a format that we are comfortable with. And the format is where we have the x squared term as the first term, the term in x as the second term, and the constant term as the last term. So what that means is that we will rearrange this into x minus x squared minus 6x plus 27 is equal to 0. Right? That's the format that we will put it in, where the x squared term is up front, then the term in x, then the number. And in the method of factors, what we do is we multiply a by c, or ac, and we need to find the factors of that product that, when added together, give us b, which is the coefficient of x. Now, ac, therefore, will be a, which in this case is minus 1, multiplied by c, which will be positive 27. In that equation, b was equal to minus 6. So ac, as we said, will be minus 1 multiplied by 27. Is that correct? Minus 1 multiplied by 27. Minus 1 by 27 is minus 27. Are we okay there so far? And b, we said, was minus 6. b was minus 6. So we have to find the factors of minus 27 that, when added together, give us minus 6. So very quickly, we could see that 3 multiplied by 9 is 27. So I'll write that down. 3 by 9 is equal to 27. Now, we don't want 27, we want minus 27. So what we have to do is we have to select either the 3 as negative or the 9 as negative, so that when we multiply those two numbers together, we'll get minus 27. But to decide which one we allocate as the minus, we have to recognize that when we add whatever we choose for these first two here, we must end up with minus 6. And the things that we'll be adding is 3 and 9, but one of them has to be negative. So which one of them would have to be negative so that when we add it, we get minus 6? The 9. The 9 has to be the negative one. So it'd be 3 minus 9, and that would give us minus 6. And therefore, we'd use that same thing on the other side. We'd have 3 and minus 9 here. So that when we multiply 3 by minus 9, we will get minus 27. And when we add 3 and minus 9 together, we'll get minus 6. So therefore, we would have, by that deduction, realized that the required factors are 3 and minus 9, because those are the unique factors that will do what we want to do. That is, when multiplied, they give us minus 27, and when added together, they give us minus 6. So we will utilize this information in the next line. So we would say minus x squared, instead of the minus 6x, we will use the 3 and the minus 9. So we'll have 3x minus 9x. That will replace the minus 6x now, coming from our information, which is this. Plus 27 will be equal to 0. So that's how where we reach. And then we just proceed using factorization by grouping. So in this first pair, we'll take out either minus x or x. X is the normal one we take out, so you take out x. And what we'll have inside of here is minus x plus 3 and we need to end up with minus x plus 3 here as well. So what we'll do is we'll take out plus 9, and that will give us minus x plus 3 in brackets. Don't forget that this is equal to 0, so we put it back. Then what we do is we recognize that minus x plus 3 is common, so we'll take that out as a factor now. So we get minus x plus 3 as our factor coming out. And in the first pair, if we take minus x plus 3 out, we'll end up with x. And in the second pair, if we take minus x plus 3 out, here we'll end up with positive 9. And don't forget, all of that is equal to 0. So then this would imply then that either minus x plus 3 is equal to 0, or x plus 9 is equal to 0. Either or. Either this is 0 or that one is 0. So that would imply now that either minus x is equal to minus 3, or x is equal to minus 9. What I did here was minus 3 on both sides, and I minus 9 on both sides. So that's how I got this line here, this line here. So now, I come down and say, either, from this one, I don't want minus x, I want x. So, there are two things I could do. I can multiply both sides of the equation by minus 1, or divide both sides of the equation by minus 1. It doesn't matter what I do. In either case, if I multiply or divide both sides of the equation by minus 1, I'll end up with x is equal to 3. And I've already solved for x in the next equation 3, or x equal to minus 9. Now, if we were in doubt about what we were doing, all we had to do was try back these into the equation and see if they worked out. If it worked out, then we know our solution is correct. So if in the exam we were unsure, we could check it. So let's do a quick check to see if what we have is correct. This is our check. If you don't have time in the exam, you just go on, right? But as we have the time now, we'll just check it. And if we substitute x equal to 3 into our equation at the top, let's see what happens. we'll have minus x squared, let's use the bracket, so x will be 3 squared minus 6 multiplied by x, which in this case is 3, plus 27. Let's see what that works out to be. Minus 3 squared. Now 3 squared, we'd have to square the 3 first. That 3 squared is 9. But then we have the minus on the outside. So this works out to be minus 9 here. Minus 6 by 3 is minus 18. And then we have to add 27. What happens here is that the minus 9 and the minus 18 gives us minus 27. And then if we add 27 onto that, what we'll get is 0. And therefore, seeing that the left-hand side worked out to be equal to 0, which is the same value as the right-hand side, we know that x equal to 3 is a solution. If you do the same thing with x equal to minus 9, you will get the same answer. I know I'm confident that what we did there is correct. You will get the same answer. Okay, so take it down and we'll move on to the next one. Okay, so the second method we'll be using to solve the equation is the quadratic formula. And in the quadratic formula, we say x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Now I'm sure once you did that homework, you'll see that it's coming there almost automatically, and you only used it 3 times. So imagine if you use it about 3 more times, right? And you do that a few times until you come to the exam, it will stick. So it is not as difficult as you think it was initially. So if we were to do the substitution here, we'd say x is equal to minus, and in brackets, we will put b, right? Because b is a negative 6, so you must be careful and make sure you put your brackets. Plus or minus the square root of b squared, which will be minus 6 squared, minus 4, multiplied by a, which was minus 1, multiplied by c, which is 27. And all that is divided by 2a. Just 2 multiplied by minus 1. Okay, so that's what that comes down to be. So it means then that x will be equal, minus 6 is plus 6, plus or minus the square root of minus 6 squared is 36, minus 4 by minus 1 is positive 4. Positive 4 by 27 is positive 108. And all that is going to be divided by 2a, which is minus 2 when we do the multiplication. So what happens then? X works out now to be 6 plus or minus the square root of 144 all over minus 2. So x is equal to 6 plus or minus 12 all over minus 2. So if we take this and we come up here, what we realize is that x is equal to 6 plus 12 over 2, or the other possibility is that x is equal to 6 minus 12 over minus 2. Minus 2. So what happens now is that that implies that x is equal to 6 plus 12 is 18 over minus 2, or x would be equal to 6 minus 12 is minus 6 over minus 2, which implies that x will be equal to minus 9 or x to be equal to 3. And if we recall our first solution, we got by the method of factors x equal to minus 9 or x equal to 3. So it means that the two methods agree. And this is also an acceptable method. Okay, so we are going to use the third method now to solve this question. And the third method is where we use the completing square format. Now, in the completed square format, we express the equation in the form, in the required form, of a into x plus h squared plus k. All right, that's the form. And in this form, h will be equal to b over 2 multiplied by a. And k is equal to 4ac minus b squared all over 4a. Right? So I ask that you commit that to memory so that in the event that they don't give you that, as a matter of fact, they wouldn't give you that. They might give you the form of the completing square, but not what h is and what k is. So you need to memorize that. You need to memorize that. So in this case then, let us work out what each one of those would be. Let us work out what h is. H would be equal to b, which is minus 6, all over 2a, which will be 2 multiplied by minus 1. This works out to be minus 6 over minus 2, which works out to be 3. So what we are saying is h is equal to 3. Let us work out what k is. K is equal to 4 multiplied by a, which is minus 1, multiplied by c, which is 27, minus b squared, which would be minus 6 squared, all over 4 multiplied by a, which is minus 1. Right? So this works out. This implies, therefore, that k now will be 4 by minus 1 by 27, which will be 108, minus, actually it will be minus 108, because 4 by minus 1 is minus 4. Minus 4 by 27 is minus 108. And then this is minus 6 squared. Now minus 6 squared will be 36. So it will be minus 36 all over minus 4. So this implies that k now is going to be equal to minus 144 over 4. And if you work out k in this case, you get over minus 4, sorry, you get a positive result because both signs are the same. 4 into 14, 4 3s are 12, 13, 14, 4 into 24 is 6. So you'll get k is equal to 36. So we'll just highlight that because you know we're going to have to use it back. And here we had h was equal to 3. So we highlight that as well. So we come back across here now. And we will use our equation, our completed square format. Okay? This here was supposed to be equal to 0. So let's put that in place now. A is minus 1. So we'll put that in. Minus 1 into x plus h. We know h is 3. So it'll be x plus 3 squared plus k. What is k? K is 36. So we put plus 36 equal to 0. Now, from here, we could write that minus 1 into x plus 3 squared is equal to minus 36. What I did was minus 36 on both sides of the equation. So this is how we ended up with that. So what happens now? This implies that if we divide both sides of the equation by minus 1, to remove this minus 1 times the x plus 3 squared, divide both sides of the equation by minus 1, we'll get x plus 3 squared is equal to 36. Because I'm dividing by minus 1 here, I'm dividing this by minus 1, so I'll get this. What happens next? I'm going to remove the squared sign on top here by finding square root. The square root on the left-hand side will give me x plus 3, because the square root removes the square sign. And if I find the square root on the left-hand side, I must find the square root on the right-hand side like this. So what happens is I get x plus 3 is equal to plus or minus 6. Plus or minus 6. So what happens next? I'm going to get rid of the plus 3 on the left-hand side by minusing 3. So I get x is equal to minus 3 plus or minus 6. What did I do again? I minus 3 on the left-hand side, so I remain with x alone. And I must do the same thing on the right-hand side. So here's my minus 3 on the right-hand side. So what happens next? Minus 3 plus 6 is one possibility for x. Or the other possibility is x will be equal to minus 3 minus 6. Because remember, it's plus or minus. So what we did initially is we considered the plus, and then we considered the minus options. So that would imply that x is equal to minus 3 plus 6 is 3, or x will be equal to minus 9. And again, it agrees with the other two solutions. The first two, x was 3 and x was minus 9. So it says that it all works out as we would like it to.